Now, there's a green flyer floating around the school. Like there's one on the door at AT3. That person is a retired instructional assistant, and she's been doing tutoring for probably a decade and a half. And she knows these classes really well. It's not free though. I think it's $20 an hour. Just FYI, she takes groups also. These are these I'm going to give you now are online, but they're free and they're quite good. Okay, the first one is the most boring one, but the most comprehensive. That's the Khan Academy. But it's really boring, but it's quite good though. And they use they have example problems as well. It's just pretty well done. And I'd like to encourage you to go on TED Talks and listen to him. He gives a really good talk on how he's using AI in his Khan Academy. It's fascinating. And I meet a lot of my friends are retired teachers, and they all are just poo-pooing AI. And they always say, "Give me one good example in AI." Well, Khan Academy, a really good example. Okay, now this one is weird because it started off with an organic chemistry tutor, but it's spread significantly. It does everything in the world. It does biology, chemistry, all kinds, physics, geology, but it's not. It's called the organic. Um, there's one more I've got to block. Tyler DeWitt, another good site. Now, all these people are very consistent with the way I teach MA. And if you find a tutoring site, and there are others that are also quite good. And just to be careful if you have a site that does things differently than I do, or you'll get confused that way. Try to stick with the sites that do it the same way I do. For sure, these sites do. Okay? And if you've got any, does anyone else have any sites that they particularly like? Okay, I'd also encourage you to get in a study group. There's a ton of research to show that student achievement is higher for those students participating in a study group. I mean, it's significantly different. Some of you are loners and you like to study by yourself. You will still benefit by being in a study group. Okay. While I'm on this is the study guide for test one. We'll be doing sig figs, metric conversions, multi-step problems, and a take-home problem. Okay, so let's go ahead. All right, this is the problem-solving process we're going to be using for the rest of the semester. Number one is if there is a chemical reaction, balance the equation. Now, unit one has no chemical reactions. And for unit one, you're going to go to step two. Unit two, we're going to get into chemical reactions big time, along with chemistry stuff. So step number two is what's given. What information do you have is given? Now, in your take-home problem, I'm going to give you a page of givens. And you got to go through there and figure out what's superfluous and what's strategic. Okay, what are you trying to calculate? Number three. And lastly, the setup. Now that's where you take the given and you can do a series of conversions to to what you're trying to calculate. Now this will all make sense by the end of today's lecture. All right. Now for this class, there are a few more types of problems, but for our class, these are the three type problems you're going to be doing in here. I'm going to practice those today, and you're going to be used in your dry lab 2. All right, going from the given to calculation. Now there's three ways to do that. You're going from linear to linear, square feet or square whatever, and then cubic. That's one type of problem with three subtypes. Okay, number 2 is fractions. If you're given as a fraction, your calculated answer needs to be a fraction as well. So fraction to fraction, if you start with a fraction, you got to end with a fraction. If you start with something that's just linear, like 10 feet, you cannot end with a fraction. They've got to match. And there are other types of problems as well. Now, if you like math, see all the sad faces out there. If you like math, there's a lot of really cool online kind of problem solving sites you can go to that give you practice problem. I'm on a lot of those, and I'm always getting, if Mary does X amount of work in so many hours, and Ted does work in so many hours, and you combine them together, how much time will be that's another type problem. Yeah, I get these all the time, a lot of geometry problems and stuff. So it's really fascinating. If you don't like math, don't do it. All right, so do these make sense? Okay, so given what you're trying to calculate, setup. Now, if you don't have a calculator in here, because I weight your answer. Say in the test, I go blah, 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 and you do the setup all the way through the setup and don't have a calculator. I always have calculators to loan, by the way. But let's say you didn't want to use your calculator. You just said, I'm going to leave it like that. I give 90% of the credit to the setup, not the answer. The answer is worth 10%. So where I'm going with this is you can get an A in this class without using your calculator. Because you get 90% of everything, which is an A. Okay, so I'm going to do one more little cutesy thing. If you start with A and you multiply A by C over A, what's the answer to that? Huh? What's the answer to that? Well, if I have what's this answer? Answer is 4. And notice if you cancel the 2, you're left with what? 4. Up here at the top, A's cancels, so we're left with C. So we're going to be in this. So this process we're going to be going through. Some people label it as unit cancellation. Other people call it dimensional analysis. One and the same, though. All right. Now, one other thing. What did you say? Dimensional analysis. Okay, these are the conversion factors we're going to be using in this class. Now, At the first page of Dry Lab 2, you've got a conversion factor page similar to this. Mine is better. What I did is went through and bold-faced everything that has infinite sig figs. What they did on your first page of your Dry Lab is they italicized it, and it's just too subtle. Other thing is I redid the metric part. Well, yeah.
Is this conversion legal on Canvas as well?
Yeah. Yeah, it's under file. Also, it's I believe I have it a couple different places, but but it's also in Canvas. The one in your packet, I don't want you to use. I want you to use this one instead. Also, it's got this guy here, which is not in your packet. Okay, so whenever we have a kind of a set of numbers that are supposedly equal, like for example, 12 apples is equal to 1 dozen. We can make that into a fraction. As long as these two are equal, you can make it into a conversion factor. If they're not equal, no conversion factor, no exceptions. Now, whenever you have a conversion factor that's a fraction, you have its inverse as well. So 12 over a dozen, or 1 dozen over 12 apples. 12 of anything's a dozen. Now that's by definition, so that's infinite sig figs. So over here, all these are fractions. So your conversion factors will always be fractions. And whenever you have one conversion fraction, you automatically has its inverse. Automatically. So you always have, they go in pairs. And the trick is to choose which one is correct and which one doesn't work. Now I'm going to show you a way that you don't have to worry about that. You'll automatically know. Okay, so how many dozen apples are in 34 single apples? Step number 1, what's given? Well, first of all, there's no chemical reaction. So go right to given. What is given? 34 single apples. That always goes on the left. Whatever is given on the left. What are we trying to calculate? How many dozens? That goes on the right. Always. No exceptions. Given on the left, what we're trying to calculate on the right. Black and white. No gray areas. Now, the last step is the conversion process. How do we convert apples to dozens of apples? What conversion factor are we going to use? Well, here's a conversion factor that's got apples and dozens in it. But we have 2 of them. Which one are we going to use? Okay, and I want you to think about where you answer that, this here. So basically, the given has to always cancel. So, which conversion factor has apples on the bottom? Because with apples on the bottom, your given will cancel. So is it the top one or the bottom one? Bottom one. And what are we left with? Dozens. What are we trying to calculate? Dozens. So that's the setup. Here's the given. We're trying to calculate and conversions every single time. Now, this is a one-step conversion. This is the easiest and most straightforward. Sometimes we're going to have multiple steps. DryLab 2 has got a lot of problems with multiple steps. Some are single step, some are multi-step. Your take-home problem for test 1 is going to be multi-step. In fact, it's going to be multi-step. That's why it's a take-home problem. All right, so 90%. This problem's worth 10 points. You're looking at 9 points. No calculator yet. Okay, so sig figs. Well, we've got 2 sig figs here. How many on the conversion factor? Well, is that by definition? 12 apples to a dozen, 12 eggs to a dozen. Is that by definition? Yes, that's right. So it's infinite. Sig figs. That means it doesn't enter into the significant figure calculation. 2 sig figs does. So our answer is going to be, let's see. 2.8 doesn't. Yeah. Together, they're infinite. Because it's by definition. You look up in the dictionary, define a dozen, it'll tell you 12. Not 12.1, not 11.9, 12, exactly. Exact numbers have infinite precision.
You divided the 12 into the 34?
I did 34 by 12.
Okay.
And then you round to 2 sig figs. That makes sense?
Yes.
We're going to do lots of examples. All right. So that's your first dimensional analysis. The first unit cancellation. Unit cancellation, notice we're canceling the units to figure out which conversion factor we need. So stated again, given always cancels out. No exceptions. Your first conversion factor has got to cancel the given. So that means it's got to be on the bottom. If it's ducks, ducks got to be in the bottom. It's centimeters, centimeters got to be in the bottom. Grams, grams in the bottom. And then some problems are one step, others are multi-step. Okay. How many inches are in 34 centimeters? What is given? 34 centimeters. Look for the number. That'll give you a clue as to what's given. So the number here, the only number there is 34. And what we're trying to calculate are inches. So given goes on the left, calculated on the right. Now we need something with centimeters in the bottom, so it cancels. And it'd be nice if inches were on the top of our conversion factor, then it'd be a one-step problem. So let's go over to our conversion factors, and here we have inches and centimeters. Perfect. Okay, so we're going to have remember, you always have two conversion factors, which is they're related through the inverse. Okay, so which one are these going to use? What did we start with over here? Centimeters, so centimeters have got to cancel. So the centimeters has to be in the bottom. So that means we're going to use the top one. Okay, so notice this boldface. That means it's infinite. It's by definition. So our answer is going to have two sig figs. Okay, does that make sense?
So
Okay, so let's try one. Answer is 13 inches.
that's 50.
Notice a couple details. The given cancels. Next step is to calculate sig figs, so we can calculate sig figs for the answer. If it's by definition, it's infinite, or if it's bold-faced on this sheet. And yes, I'm going to give you this for the tests. People always, do I have to memorize this? No. Now, the metric ones we're going to be using a lot. So some of those you'll automatically know because we use them so much. Okay, so we're looking at miles and inches. Which is more, miles or inches? Miles. So that means our number is going to be less than 1. So if your answer is more than 1, your setup is wrong. Okay, so what's given? So we need inches on the bottom, so it cancels. All right, so let's go over here. Okay, so we've got feet in miles, but not inches in miles. What do you think we should do?
Figure
Hmm?
out how many feet.
Convert to feet first. Exactly. Good. So this is going to be now a two-step problem because we have to go from inches to feet. This is supposed to be centimeters, even though I can't read it here. It looks like inches. It's supposed to be inches here. Okay. All right, now we have feet. Now we can use the feet to miles. Right there, 5280 feet per mile. So for the next conversion factor, the feet has to cancel. That means it's on the bottom. So the bottom line in these problems is everything has to cancel except what you're trying to calculate. If everything cancels and you're left with something that's not what you're trying to calculate, you're either going to have another step or two, or the front part of your setup is wrong. It's just cancel city. Now we're going to be doing this for unit 1, 2, and 3, this cancellation bit. So it's extremely important you see this. And I'm going to be using this, I'm not going to change it all. What's given, what are you trying to calculate? We get into molar calculations, we get into concentration calculations. What's given, what are you trying to calculate? What's given, what are you trying to calculate? The whole time. So by the time May comes around, you're going to know this unit cancellation bit really well. Okay, so problem is set up 90% credit right there. So we're going to, now this is like the last page of unit 1, where you've got multiple things going on in one problem. So everything on the top, we're going to multiply, hit the divide key on everything on the bottom. So I'm going to rewrite this a little differently. I'm going to connect the fraction bars. So instead of brackets, I'm using a vertical line. Some people call this railroad tracks. Okay, so again, I'm going to multiply everything on the top. All those ones we can ignore. I'm going to hit the divide key on the bottom twice. Once for the 12 and once for the 5280.
Said ignore the one.
Yeah, when you put it in your calculator. So we're going to go 12 divided by 12 divided by 5280. And we're looking at 2 sig figs again. And these are infinite again because they're by definition. Okay, so we're looking at 1. Okay, now that's 4 sig figs, not 2. So we need to go to 2. That means the 9 kicks the 8 up to a 9. That's your answer. 1.9 times 10 to the minus 4 miles. Okay, everyone get that?
Sorry, I missed problem here, but I got 0.0008 and you're moving it.
I just put in scientific notation. You're gonna have 0.3019.
What is that? 3 zeros and then 1 8.
But you have to do 2 sig figs.
Yeah.
So the 9 makes the 8 a 9. Over here. Yeah, that 9 makes it 1.9. Or 0.0003019.
Okay, most of it, it just have 2 days, didn't it? So 1.8.
Yeah, it depends on what your, my calculator set up for scientific notation automatically. Okay, well, you can convert it. I can show you how to do that if you want. Okay, so the other answer is gonna be. That's the answer you got, right?
Yeah, yeah.
Yeah.
Wait, you want us to move the decimal?
Well. I think the bottom number is awkward. That's why I put it to scientific notation. It's never wrong to put it in scientific notation. Never. The other numbers, it varies. We're gonna have, in unit 2, we're gonna be working with numbers that are extremely small, like 29 zeros, 24 zeros after the number. That's how huge these numbers are, how small they are. That's why we better learn scientific notation.
So like, for example, 1.9 times 10, it's just telling you how we reduce that number to make it look awkward, right? It's just showing us, it's not exactly 1.9, but it's.
Well, after you rounded this one.
Okay.
Yeah.
So I think about. This, is that from? Here,
When you divide 12 divided by 12, divided by 5280. And then convert it to 2 sig figs.
So, yeah, but the 4 is that, where's that from? Is it the X10 to? That's how many numbers are left over. Rounded.
That's how many decimal places you have to move. Yeah, because 0.00019 is awkward. Awkward numbers you convert to scientific notation. And that's not a fraction either.
Get to the, I don't think it'll get. Okay, I just wanna make sure.
Yeah, the exponent is always a whole number, never a fraction. All right, well, that's your first two-stepper. You know where it is?
Yeah.
Okay. All right, well, let's move on here. Okay, how many centimeters are in 1.23 kilometers? Which is bigger, centimeter or kilometer? Kilometer. So we're gonna have lots of centimeters in our answer. Lots. Centimeter is about that long, 2.5 centimeters to an inch. That long, not very big. And a kilometer is smaller than a mile also. Okay, so what's given is kilometers. And we're trying to calculate centimeters. Now, we're in the metric system. I want you to think about a base unit in the metric system. So if we're talking about kilometers and centimeters, what do you think the base unit of that is? Meter. If we're working in, let's say, grams, milligram to kilogram, what do you think the base unit on that is? A gram. So this is the mentality I want you to think about. Convert to the base unit, then from the base unit to whatever you're supposed to go. And we're going to see this in unit 2 also, because the base unit in unit 2 is going to be the mole. Chemical and physics base unit. So I always say, if in doubt, convert to base unit. It means it's going to be a multi-step problem. Sometimes people who are raised in another country, there's only like, I think 6 countries that use the British system. We're one of them. Back in 1986, something like that, Ronald Reagan, we were on the road to converting the United States to metric, and Ronald Reagan killed that program. He thought it would confuse too many people. He was probably confused by it. And so the world is metric except us. Huh? Yeah, not exactly. And Burma is no, they don't call it Burma anymore. It's anyway, they don't call it that anymore. There's another name they go by. Okay, so we're talking about centimeters and kilometers. So we're going to convert centimeter to meter and meter to kilometer. So you need to know how many centimeters there are in a meter. Now, this is a tough one, but think about money. How many cents are in a dollar? 100. So that means there's 100 centimeters in 1 meter. So centi is, think cents. Kilo. 1,000. So there's 1,000 meters in 1 kilo. Okay, so step number 1 is we're going to the base unit. So our given has to cancel.
We would have found.
Meters. Okay, now we need to go from meters to centimeters. Meters has got to cancel. And there are 100 centimeters in a meter. Now, what is left over if we cancel everything out? Centimeters, and what are we trying to calculate? Centimeters. Okay, so I'm going to set it up using that other way as well. And you're free to use either one of these. Now, if you haven't done much of this, the purpose of Dry Lab 2 is to do lots of practice. I also have extra worksheets in Canvas on metric conversions, for example, and all kinds of stuff, dimensional analysis worksheets. Lots of practice with answers. Always, my worksheets always have answers. Okay, so does that problem make sense now? All right, so let's do,
So if it's on like top and left place.
if it's on the top,
You divide it.
everything on the top, you hit the multiply key by. And then you hit for everything on the bottom, you hit the divide key.
So.
Right.
So the sig figs is 3 and the original is, so why wouldn't we just stop at 123? Because that's 3 sig figs. Why do we go to 1.23? For scientific notation.
Okay, this. Okay, this is three sig figs, right? And this is infinite because metric system is all by definition.
So the original, when you first did it, before you move it to this, three. So you got 1.23, but it was, like 12,000 or 123,000. So if we're moving it, wouldn't we just, why don't we just get rid of the zeros and make it 123? Why is it 1.23?
That's a given. That's what you're starting with, right? That makes sense?
Yes.
Okay, so those are examples of what I call linear. Starting with a single number and you're ending with a single number. What's going to happen if we start with a fraction? Now, the thing about fractions, a lot of people have a lot of problems with fractions. But think of a fraction as two problems in one. Okay, so given is 34. miles per hour. That's the given. That means our calculated has to be a fraction. No exceptions. Start with a fraction, end with a fraction. Okay, and a fraction to end with is going to be kilometers per second. So my advice on this type of a problem is do it in two steps. One step is to calculate the top part of the fractions and then calculate the bottom part of the fractions. In other words, numerator, denominator. So which do you want to do first? The time or the distance? Time, okay. That means we're going hours to seconds. So the hours have to cancel now. And we don't have a conversion factor to go from hours to seconds, hours to minutes, though. So hours cancel. And oops. Okay, now we've got seconds on the bottom. That's what we want. Everyone see how after everything cancels, we have seconds on the bottom? Now we're going to convert the miles to kilometers. Okay, that's right at the top here. Okay, so everything cancels except for kilometers per second. So we're going to break this down into two simpler problems. So everything on the top we multiply, everything on the bottom we hit the divide key. So we're going to go, yeah,
Miles cancel each other out.
miles into, okay, you're looking at miles from the beginning, miles at the end, cancel out. Yeah, Yeah, right. And that's a good one to say, that doesn't work. Yeah, it can be, we can have 29 sub-steps here. 1 and 29 can cancel.
Oh, like from the beginning, oh, to the end. Oh, I didn't know. Okay.
Okay, so we're gonna, see here, 34.4. And we're looking at 3 sig figs, so it's gonna be. Or. So start with a fraction, end with a fraction.
Big one. Divide.
Okay, any questions on that? It's -2, not 3.
You write like a doctor.
Question, you getting 15.37? I'm doing 3, I already told you that's
Yeah, 1.537 is 4 sig figs. So the 7 kicks the 3 up to a 4.
So 15.4. And then I'm gonna. This is I'm doing 34.4 times 1609 divided by 15 divided by 60. And that's what I can get.
Okay, you multiply 34.4 by 1609.
Yeah.
If you divide by 60, divide by 60.
Yeah, one. And I can get a bigger number, 15.67. Little violence. More than the track. Oh, I'm doing. Oh, okay. Oh, thank you. I forgot.
All right, we okay with this? Yeah. How, I'm not sure your question. Say again? Okay, so I'm going 34.4 times key 1.609, divide key 60, divide key 60, enter.
Calculator. What's like they punch it in as well, so we can like a visual. Yeah. So we got the calculator app on your computer. Let me see.
Um.
Maybe one of your, keyboard at the very bottom, you know, where all your apps stuff, if you type in calculator, or is it this button, so the Windows does, the very top of your computer. Yeah, right there, there you go. And I believe you can do it standard or the bigger, calculator, where it's a standard, there's a little box. Let's do it, let's try that, the next. Or just put it, yeah.
All right. So we're gonna do this. This is what you're after, right? Okay, so we're gonna go. Got the problem. It was, okay, so we're gonna go 34.4 times 1609 divided by 60 divided by 60, enter. Okay. Now we need to go 3 sig figs. So that's right here. So the 7 makes the 3 of 4. So it's 0.0154. That makes sense? Okay. And did you do, what did you do differently? I've never used that before.
Yeah. Fingers.
Yeah, I think it just comes with Windows. Good. I'm glad you told me that.
Thank you.
I mean, I literally have been,
Thank you.
okay, so let's continue with this now. Okay, a plane burns 34 liter, notice I use 34 a lot. If a plane burns 34 liters of jet fuel per. All right, so I want you to flag the per, P-E-R. That means it's a conversion factor. Because a per is a fraction bar. So we've got, so that's what that's what's given. So we're going to start with that. So we want 34 liters per second. And we're trying to calculate gallons per hour. Now, it's an interesting story about this problem. The true story. A 737 was fueled up in Canada, and they put the wrong amount of fuel in. They were thinking imperial rather than metric. And the plane ran out of gas halfway across Canada. Because they didn't put enough fuel in because they were in the wrong unit system. Okay, so we want to end up with, instead of liters per second, we want gallons per hour. So it's fraction to fraction, that means there's 2 problems. So we can do the liters to gallons first or seconds to hours first. Which do you want to do? Does not matter.
30, 40, 40 liters. What is the first fraction thing?
34 liters per second.
Oh.
Then the first line up there, you see the per. Whenever you see per, think conversion factor.
Oh. The first red division, it says 3 ML. I wasn't sure what that was.
Oh,
Yeah. Oh, should be 30.
the rest of the 4 didn't show up. Right. Okay, so let's do the seconds to hours first. So we need to have the hours in the bottom. Okay, so seconds needs to cancel, so we're gonna have 60 seconds. 1 minute. Now seconds cancels. And then 60 minutes to 1 hour. So now hours on the bottom, we want. Okay, now we need to convert the liters to gallons. Okay, we have one stepper. Okay, so I got to remember 3785. I'll do that wrong. Okay, so liters cancels. We have gallons per hour. Okay, so we're gonna go. I guess we can do the.
Because I got, 323381,000. Yeah, I'm like, 52. My decimals are not lined up to the point. The calculator on the computer, but it was 25 by 60.
Let me just do it again.
Oh.
Did get another number. I left off a 3. So this is not the right answer. Or 32,000. Okay, so I'm going to leave the square and cubic stuff till tomorrow. Okay, You're gonna have one of these. And the reason why this is a little more complicated because you take the linear conversion factor and then convert it to the square conversion factor or the cubic one. And there's a fair amount of explanation going on. And we're at 1:15 now. Okay.